Hello and welcome to my channel We Learn by Sharm. I am Shraddha Banode, Assistant Professor in Electrical Engineering Department of St. Vincent Pallotti College of Engineering and Technology, Nagpur. Thank you so much for giving so much love and appreciation to the lecture series of synchronous machines. As per request, I am starting with another series which is on transformer. So basically, I will be covering the topic transformer, which comes under electrical machines 1 in some universities, while in electrical machines 2 in some other universities. So let's get started. While understanding the topic transformer, we will try to understand the construction, its working principle, EMF equation, what is ideal transformer, what is ideal transformer on no load, what is practical transformer on no load, what is practical transformer on load, the losses which takes place in the transformer, its efficiency, open circuit and short circuit test to get the efficiency and regulation, equivalent circuit, and how to find out voltage regulation. So let's get started. First, concentrate on construction. Before that, let's try to understand what is transformer. So it is nothing but a static piece of apparatus by means of which the electric power gets transformed from one circuit to another circuit without change in frequency. So here, this is the proper definition of transformer where you have to pay attention on it is a static piece of apparatus. What do you mean by static? Basically, transformer is a machine. Basically, transformer is a machine. Now, when we say machine, it always comes to our mind it has rotating parts. But this is a machine with no rotating part, and that is why it is called as static piece of apparatus. Okay, so the transformer is a static piece of apparatus. It is a static piece of machine by which why we use it to transform electric power from one circuit to another circuit, and when it does so it does it without change in frequency, right? So I repeat, a transformer is a static piece of apparatus by means of which electric power in one circuit is transformed to electric power in another circuit without change in frequency. Let me tell you, the frequency doesn't change in another circuit. I hope this is clear to you. Now when it does so, it can either level up the voltage or level down the voltage. So if it raises the voltage, it is called as step up transformer. If it lowers the voltage, it is called as step down transformer. Now we generally use this term step up transformer or step down transformer depending upon the voltages, whether it increases or it decreases. But when it does so, it actually reflects on the current also. So basically when the voltage gets increased, it is a step up transformer, the current gets decreased. And when the voltage gets decreased, it's step down transformer, the current increases. Right? So this is how the current, when you say step up, step down voltage, it does so with the corresponding change in current. Okay. The transformer works on the principle of mutual induction. I hope to understand the transformer better, you must know the concept of mutual induction first of all. Now when we talk about construction, constructionally it is divided into two parts. Constructionally it consists of two parts. One is the laminated core and another is the inductive coils. Okay. When we say laminated core, it means the core is there. So what we think that the hard core, iron core is there. Okay. Yes, iron core is there, but it is not a solid core. It is made up of very thin laminations. Okay. And those laminations are clapped together to form that solid core. Alright. And it also consists of two inductive windings. Two windings are there which are wounded on the limbs of this core, and it is highly inductive in nature. Ideally, it should have zero resistance, but practically it has very, very small resistance. Alright. Now, few points when we must keep in mind when we talk about construction is that the two windings are always insulated from each other as well as from the core. In fact, each and every turn of the winding is insulated from each other and it is insulated from the core. Of course, if it is not insulated, then it will get short circuited. The steel which is used for the core is high silicon content material, and high silicon content material help us to avoid the hysteresis loss, and laminations avoids eddy current loss. Now, what are these losses? I'll tell you. But yes, we will use these terms to understand the construction better. Why we need laminations? To avoid eddy current loss. Why we need high silicon content? To avoid hysteresis losses. Alright, so this is very clear from this that the eddy current loss is minimized by laminating the core, and the laminations being isolated from each other by a light coat of say varnish or an oxide layer on the surface. So when you see right now on the screen, you can see there is one lamination which is kept. You must be looking like this is a two-dimensional view, and that is why you will say this is a core. But this is very thin sheet of core. Very thin sheet of the lamination is there, and I keep one more lamination on it, and I keep one more lamination on it, and I keep one more lamination on it. So like this, very thin sheets of laminations, when they are clapped together, it forms a core. I hope it is clear to all of you. One more thing you must understand when we talk about core, basically the core is further subdivided into two parts, and that is limb, which is the vertical portion of the core, and another is the yoke, which is the horizontal portion of the core. So when we name this, when we say that the winding is bounded, we can say winding is bounded on the limb of the core, and the horizontal portion of the core is called as yoke. Now, basically, depending upon the construction itself, there are two types of transformer. Core type of transformer, which looks like this, and another is the shell type of transformer, which looks like this. Now, this completely depends on construction of the transformer, whether it is core type or shell type. So, in the first thing, you can see that there is a square-like core, and you have two windings wounded on the core, and hence you can say this is a core type of transformer. But in another type, you will find that there are three limbs on the transformer. Okay, there are three limbs on the core, and the windings are wounded only on the central limb, whether it is primary winding or secondary winding, both the windings wounded on the central limb. Then it is called as shell type of transformer. Now there are various points to differentiate between this core type and shell type transformer. We will consider these points one by one, and for that you can keep this diagram in your mind so that things will be easy to understand then. Now, one more thing I must tell you is that it is not very important when you are learning at very basic level. I mean to say that this topic is included in first years also of engineering, where you just have the basic knowledge. There we don't include this part of the topic in syllabus. But yes, when you are going for a higher semesters, like in fourth semester, third semester, then you actually know how this winding is wounded on the core. Okay. So basically, when we explain the core type transformer, we show core type of transformer like this. All right. The one winding is there on one limb, and another winding is there on another limb. But actually, practically, when the transformers are manufactured, it is not manufactured like this. Then how it is manufactured? It is manufactured like both the primary and secondary windings on both the limbs. See, when we connect a supply, it becomes primary. The winding we connect a load, it becomes secondary. Basically, we don't have primary and secondary while we manufacture. We just manufacture in such a way that there are two windings. One winding is a high voltage winding, and another is a low voltage winding. Okay, so it depends. Like if you connect a high voltage winding to the supply, it becomes your primary winding. If you connect low voltage winding to the supply, it becomes your primary winding. Alright, so right now what I can say is you have two windings, high voltage winding and low voltage winding. So when you have actually when this core type of transformers are manufactured, the high voltage windings are always kept away from the limb, while the low voltage windings are always kept towards the limb. Like as I said, both the windings are there on both the limbs. So you will find that the low voltage winding is like right now you can see those rectangle, but actually it is mounted. So you can just imagine as the transformer is there, and I have just cross section it in the middle. I have just sectioned it in the middle, and you can see the cross section view of it, and then you can see that the low voltage winding is bounded just around the limbs of the core, and after low voltage winding you are wounding the high voltage winding also. Now it completely depends. Whichever you give supply becomes your primary, whichever you connect a load, it becomes your secondary. But the arrangement will be always like this. High voltage winding will be never close to limb. Low voltage winding will be always close to limb, and high voltage winding will be away from the limb. Now there are some technical reasons because of it that obviously I will tell you. Two very important point are you just maintain, you just try to keep a low voltage winding towards the core and high voltage winding away from the core, obviously for the voltage reasons. And secondly, you also give very good natural cooling to the high voltage winding. High voltage winding is high voltage, it gets heated up very fast, and that is why it should be more exposed to surrounding than to be very much closed inside the low voltage winding, and that is why the arrangement is kept like this. Again, in shell type of winding, as I told you, both the windings are on central limb, whether it is primary or secondary, or whether it is high voltage or low voltage winding. Okay, but actually when it is manufactured, the windings are not like this, but the windings are sandwich type of windings. Like you have low voltage winding, then you have high voltage winding, then some turns of low voltage winding, then some turns of high voltage winding, then some turns of low voltage winding, and then some turns of high voltage winding. But while doing this sandwich type of arrangement, you have to be very particular that the low voltage winding will be always there close to yoke. The uppermost winding and the lowermost winding will be always low voltage winding, and the high voltage winding will be sandwiched between those low voltage windings. Okay, this type of arrangement is there. Again, it doesn't matter which is primary, which is secondary. If you connect high voltage to the primary, sorry, if you connect high voltage to the supply, it becomes primary. If you connect low voltage to the supply, it becomes your primary. So it completely depends upon where you connect supply or where you connect load. But ultimately, what you need to know is that there is a sandwich type of windings kept in the shell type of transformer. So the dark one, the dark blocks representing the high voltage winding, and the light blocks representing the low voltage winding. So let's have the very fast comparison between the core type and shell type transformer. In core type transformer, the winding encircles the core. जैसे मैंने आपको बताया कि core type of transformer है और उसके दोनों limbs में windings है, तो जो maximum winding, the maximum portion of the core is encircled by the winding, and the winding is more exposed to atmosphere. While in shell type of transformer, what happens? All the windings are on central limb, and you can see the core is surrounding the maximum part of winding. So the core encircles the most part of winding in shell type of transformer. In core type of transformer, it has single magnetic circuit. In shell type of transformer, it has double magnetic circuit. Now, what do you mean by single magnetic circuit and double magnetic circuit? So when you give supply, when the flux will be generated, it will have only one path through the core in the core type transformer, and that is why it is a single magnetic circuit. But what happens in shell type? The winding is there on the middle limb, so when the flux will come out, it will bifurcate and it will complete its path through both the other limbs, the outer limbs, right? And hence it is a double magnetic circuit. In core type, obviously the core has two limbs. In shell type, the core has three limbs. In core type, the cylindrical coils are used, while in shell type, the multi-layered disc or sandwich type of coils are used. जैसे मैंने आपको बताया कि कोर टाइप में क्या होता है कि पहले आपने लो वोल्टेज को पूरा की पूरा सिलेंड्रिकल में रख दिया, एक साथ पूरा बंच रख दिया, ठीक है ऐसे. एंड क्या होता है कि और उसके ऊपर क्या किया आपने, उसके ऊपर आपने हाई वोल्टेज वाइंडिंग रख दी. तो लिम के ऊपर पहले लो वोल्टेज का सिलेंड्रिकल टाइप ऑफ पूरा की पूरा वाउंडेड कॉइल रख दिया और फिर उसके बाद हाई वोल्टेज का रख दिया, ठीक है. लेकिन शेल टाइप में क्या होता है, सैंडविच टाइप होता है. पहले लो वोल्टेज रखोगे थोड़ा सा, फिर हाई वोल्टेज, फिर लो वोल्टेज, फिर हाई वोल्टेज, फिर लो वोल्टेज, फिर हाई वोल्टेज, फिर लो वोल्टेज, ठीक है. सो सच टाइप ऑफ मल्टी लेयर अरेंजमेंट इज देयर. The windings are uniformly distributed as far as core is concerned, and that is why natural cooling is possible. जैसे मैंने बताया कि जो winding है काफ़ी exposed होता है atmosphere को, and that is why the natural cooling is very much effective in core type of transformer. While in shell type of transformer क्या होता है ना कि winding के across core है, तो बहुत ज़्यादा एक्सपोज नहीं होती है वाइंडिंग एटमॉस्फेयर को, और इतने नेचुरल कूलिंग इतना पॉसिबल नहीं होता, थोड़ा बहुत होता है बट एक्चुअली वो नहीं के बराबर होता है. सो यू डोंट हैव द नेचुरल कूलिंग इन शेल टाइप ऑफ ट्रांसफॉर्मर. इन को टाइप ऑफ ट्रांसफार्मर कॉइल्स कैन बी इजीली रिमूव फॉर मेंटेनेंस. एक साथ पूरा की पूरा बंद निकाला, उसको मेंटेनेंस दे दिया, कनेक्टिविटी देख ली, सब कुछ चेक कर लिया, तो वो इजी होता है को टाइप के लिए. जबकि शेल टाइप के लिए थोड़ा डिफिकल्ट होता है क्योंकि सैंडविच टाइप है, तो आपको पूरी वाइंडिंग्स के जो सैंडविचेस है वो निकालने पड़ते हैं टू चेक द प्रॉपर कनेक्शन इन वाइंडिंग. Core type of transformer is generally used for low voltage transformers, while shell type of transformers are generally used for high voltage transformers. The same thing which I have explained you, that in core type we don't have active. Explain करते वक्त हम बताते हैं कि एल बी वाइंडिंग एक लिंक पे रखी हुई है, एच वी वाइंडिंग एक लिंक पे रखी है, बट एक्चुअली ऐसा होता नहीं है. देयर इज ऑलवेज हाफ हाफ सिचुएशन होती है. एल बी रखा होता है, उसके ऊपर एच वी रखा होता है, यहाँ पे भी एल बी रखा होता है, उसके ऊपर एच वी रखा होता है. तो ये क्यों करते हैं? वाई इन शेल टाइप ऑफ ट्रांसफॉर्मर यू डोंट हैव प्राइमरी एंड सेकेंडरी एच वी एंड एल वी, यू हैव द सैंडविच टाइप ऑफ लेयर्स. So why it is so? Why it is done so? It is because to minimize the leakage flux. क्योंकि क्या होता है ना कि जब आपका लीक अगर वहीं की वहीं आपने रख दिया प्राइमरी वाइंडिंग भी सेकेंडरी वाइंडिंग भी, तो जो भी फ्लक्स जनरेट हो रहा है वो लीकेज फ्लक्स अवॉइड हो जाता है. जो भी फ्लक्स इवन एयर से भी जब वो ट्राई करेगा जाने का, तो वहां पे दूसरा वाला वाइंडिंग बैठा होगा उसको कैच करने के लिए. ठीक है. So these are always interleaved just to reduce the leakage flux. Same with the core type as well as shell type. तो यहाँ पे भी multi layer type होता है just to reduce the leakage flux. Half of the primary winding and half of the secondary windings are placed concentrically on each limb when you talk about core type. While on shell type you have the multi layer disc, and the high voltage coils are always kept in between two low voltage coils as far as this is concerned, just to avoid the high voltage towards the yoke. The low voltage coils are nearest to the top and bottom of the yokes in shell type of transformer. I will also give you some general points on transformers after construction, and you must know these points, may or may not be in your syllabus. But this is what transformer we always study. But you must know that the transformers are generally kept in a metal tanks. So when you will try to see transformers in the corner of your area, you may not see the transformer, you may not see the core and the winding of the transformer, but you will see the tank like structure on, and on that tank like inside that tank like structure there will be a transformer kept. The tanks are generally the transformers are generally immersed in insulated oil. The tanks are generally filled with the oil, and the transformers are kept inside that oil. Now why it is immersed? Because the coil performs two function here. One, the oil actually cools the transformer. It keeps the coil and the core of the transformer cool, because temperature doesn't rise very quickly as far as oil is concerned, and that is why oil is used to maintain the cooling atmosphere around the transformer. And also it provides additional insulation. जो oil होता है वो insulation oil होता है, and that is why whatever insulation, if the insulation problem is there in the transformer, so oil helps to give the additional insulation to the transformer. The oil should be very pure also. It should be free from alkali, sulfur. Any moisture cannot enter to the any moisture cannot enter into the tank. It is very important, because even a very small moisture, if it is present inside the tank, it will lower down the dielectric strength of the coil, and it will affect the transformer's performance very badly. And that is why the tanks are always sealed airtight to avoid any contact with the atmospheric pressure or atmospheric air or moisture. I hope this is clear to all of you. Now we will see the working principle of the transformer in next upcoming video. For that, tune to my next video. Thank you. This is Shraddha Banode signing off. Thank you and happy learning.